In this video, we are going to talk about verifying trig identities. So in this video, we're going to talk about two strategies. So first of all, it talks about the objective is to verify two expressions are equivalent. And that is what we want to verify when we are using our identities. To do this, we generally pick an expression on one side to give the identity and manipulate the expression until we get to the other side. In most cases, it's best to start with the more complicated side and try to match it to the less complicated side. You must be very familiar with your fundamental trig identities, so your trig identity sheet that you were given, make sure you have that out when you are looking at this unless you feel comfortable with those memorized, especially those Pythagorean identities. So in some cases, a direct substitution will help verify. So the first approach we're going to talk about is turning everything in terms of sine and cosine. And we talked about this with simplifying. So if I'm looking at this expression here in the middle, I would say that my right-hand side is the more complicated side. So I'm going to start with that. And I'm going to use the strategy of turning everything in terms of sine and cosine. So this cosecant would become 1 over sine. And then obviously cosine and sine would stay the same. Now, since I have parentheses, I'm going to distribute into those parentheses. And so I'm going to have cosine over sine plus sine over sine. Now, cosine over sine is cotangent, and sine over sine is 1. Now that matches the other side. So I proved or verified that the two sides are equal. So let's talk a little bit about what we did. So first we changed cosecant into 1 over sine. Then we distributed. Then we know that cosine over sine is cotangent. And that sine over sine is 1. So that's one strategy, and a lot of times we'll use this strategy in combination with another strategy, but turning everything in terms of sine and cosine is a really easy way to try to simplify or verify these identities. All right, our second approach is, in some cases, the more complicated side involves a fraction. We can split that fraction up and then rewrite everything in terms of sine and cosine. So I'm going to start with this left-hand side. And since my denominator is multiplied together, now if my denominator was added together, I could not split it up. But since my denominator is multiplied together, I'm going to say, okay, tangent of t over sine cosine minus cotangent of t over sine cosine. All right, now I'm going to turn everything in terms of sine and cosine. So my tangents become sine over cosine over the denominator. My cosine is going to become cosine over sine over my denominator. Now I got a fraction within a fraction, but remember your denominator here is a whole number, and a whole number we can always write over 1. So for this first fraction, I'm going to take the numerator and multiply it by the reciprocal of the denominator. So I'm going to have 1 over sine cosine minus, I'm going to do the same thing for this second fraction, cosine over sine times 1 over sine cosine. So then from here I see, oh, this sine and this sine will simplify, this cosine and this cosine will simplify. So I'll be left with 1 over cosine times cosine, which is cosine squared, minus 1 over sine squared. Well, 1 over cosine squared is secant squared, and 1 over sine squared is cosecant squared, which is what I wanted to verify. So I was successful here. So these are just two strategies. Actually, let's go over our approach a little bit. So the first thing we did was we split the fraction into 2. Then we changed tangent to be sine over cosine. And then we changed cotangent to be cosine over sine. Then we multiplied by the reciprocal. And then we knew that 1 over cosine is secant, and that 1 over sine, I guess squared is cosecant squared. So these are just two strategies. We're going to talk about two more strategies. But these are just two strategies we could use to verify trig identities.